There we go. Cool. Yeah, you can come speak. Who's this? Jay something?
Hello there.
What's up, teacups? Did you miss me?
Yes.
Oh, noise, baby. Oh, nice. Obama with the sub. Nice. I went ahead and
Okay.
I fixed I previously I only had icons I think up to 12 months on the Discord subs because that's like when I made it like 2 years ago. And now we have people that are up to like 18 months, 19 months, so I added all the new badges. You should have the new badges. Is this Jamarcus? Whoa, yo, what's going on, Rampton? How's the new spot?
Pretty good.
Nice.
Pretty good.
Your voice quality sounds amazing. Like, did you get a new mic or something?
No, it's just life is better.
That's dope.
Although it keeps burning in Canada, right? It's like keeps getting like more and more like.
Yeah, like I don't know. Today's really nice though.
Oh, is it? Okay.
It's really
It
nice.
is
Yeah.
92 I am right now.
Well, yeah, Florida is, or sorry, Virginia. You're in Virginia. You're in Virginia, but still, the East Coast is still hot. Yeah,
It's not that hot.
it's not that hot. Wow. Yeah, noise
Not
says
for
yeah,
Florida.
miss me. Yeah. It's what is? I was in Chicago actually last week. And right when I got, I was in Michigan, and then I came back into Chicago. And the day I came back, the air quality was like 300 or something, and it's like not good, AQI or whatever they call it. And I think it's because of there were a bunch of wildfires up in like Quebec and shit that were like fucking shit up. Nuts. Let's see the income boxing. Ooh, I do need to do that. Yes, I'll do that.
Yeah,
What's up, Ramson?
I have a nice view as well. I'll send it.
Yeah, send a picture. Let's see your view. Let's
Send
see.
the picture.
My view right now is my closet. So.
So for some reason,
I knew it.
looks better in person than in picture though.
Oh, it's okay.
But well,
Noise says he really wants to go to Chicago. I tried to look at flights to LA, 860 quid. That's actually not too bad, right? I thought
I
it's
remember
usually 1,000. You remember what? What do you remember, Teacup? What do you remember?
a passing comment from like a year ago where you said you were in your closet. And I
Yes.
always and you finally admitted that you were in your
I'm
closet.
always in the closet. I'm stuck in the closet, honestly.
I knew it.
That's true.
I
It's
know
also
what
true,
closet
too.
you're in.
all right, I sent it in the comment area.
Here, let me check.
chat.
Let's see. Let's see his
I
view.
got
He's
a
good.
nice view of the.
I'm
See
happy,
what's
dude.
happening.
I'm happy. Oh, is that the spire thing? Is that the spinny thing?
Which one?
The yeah, okay. Yeah. I know this tower. There's a restaurant up there, isn't there?
Yeah.
Yeah, this is super cool. Wow. Is this the thing that Drake has in his album cover, like Views from the Six or something?
Yeah.
Yeah, wow. Dude, this is
CN
cool.
Tower.
Dude, look at those clouds. You got some nice ass clouds too, dude. What? That's dope.
Yeah, like the weather today is really good.
That's very cool. That's super. Yeah, it's the weather. Today's actually been pretty nice too. But
Yeah,
my
for the past like 3-4 days though, it looked almost like foggy.
like
because of-
Armageddon probably because of all like the fires. Was it orange?
No, it wasn't orange. It was like grayish. Like, the week before that, there was one day that was kind of like slight yellowish,
Mm-hmm.
and but the rest it kind of looked foggy, which kind of might have also been fog to a certain degree, because like I'm assuming maybe if there's particles in the air, then the water can attach to those,
Right.
and then the fog can like come down. So it might have been like a kind of like a positive loop effect.
Yeah, it's just like becomes like a feedback cycle, right?
Yeah.
Yeah. Noise is saying, "Oh, nice album." Yeah. This was Drake's album, but that's cool. I did that. I remember it was something like it was one of these towers or something.
Yeah, it's called CN Towers. It's like the Canadian.
Excuse me.
Yeah, Canadian version. What's up? Who's saying? Excuse me. What's up? Who's it?
So I sent you a DM just letting you know.
Oh, Hamega. Oh, what's up, Hamega, dude? Your name is J. Dot. I recognize your voice.
Yeah, J. What do you mean? It's Hemega.
It says J. Dot on my Discord, dog. I'm gonna change.
For me, it says Hemega.
I'm
but,
gonna
alright.
change. I'm gonna change your nickname. Anyways, go on. What's up, dog?
So in the span of 2 weeks,
Yes.
I've actually no, like right around the beginning of June, I started working out for football.
Okay, football's dope.
And
Working out's dope.
yeah, and I'm on the team, and I got my practice jersey for practices.
Oh, sick, dude. What position are you
I
playing
sent-
in football?
I don't know quite yet.
Did you send me a DM? I don't see a DM yet. Let me see. What it
I
is.
sent you. It's probably not all the way up, but it's probably
Okay.
not in.
Yeah, let me know when it comes. When it. Oh, you mean you sent it earlier, like a long time ago?
Not earlier.
Not
I just,
really,
I
he
just sent
says.
it.
Please see. One sec. I'll
But
find
yeah,
it.
I sent you the number on my practice jersey.
Is it 24? What number's your practice?
No, it's not 24.
Wait, 1 second. I don't see anything on my DMs yet. Try signing. Or here, can I? How do I start a conversation here? 1 sec. No, do I not have you as a friend? Where is this? 1 sec.
No, you don't have me as a friend.
Well, add me as a friend, dog.
I sent
Oh,
you
there
a
you go.
friend
Here it goes. Here it is. Send here. There you go. I sent you a DM. Respond to that. What's
Okay. Oh shoot, where'd it go?
Yeah, I sent it to you. What's the other
It
big tower they have in Vegas? You know what I'm talking about? Like the Spire, Spire Tower in Vegas. This is one I think about. Yes, this, the Stratosphere.
Okay.
That's another one that's like that kind of reminds me of it, right?
Yeah, I think CN Tower is tall. Actually, I don't know. I think it might be around the same.
And then I'm trying to think. There's one other place that has like a similar, just like a massive spire.
I forgot to press send. It's
It
my
might be
bad.
Niagara as well.
Oh, Niagara. Okay, yeah. Tower. There's like a tower there somewhere or something. Niagara Falls. Yes. Wow. Look at this. What's up with these? Like they all look the same. Like did someone copy someone else's homework?
Yeah. It's like when they say copy my homework.
Yeah.
Someone copied somebody else's homework.
Noise says the BT Tower in London. Okay, this one. Okay, bro, this one's actually very interesting. What the hell? What is this tower? I see it has a bunch of radio dishes on it, but you know what this reminds me of? This reminds me of the robot in the Mandalorian. Do you know what his name is? This robot reminds me of this robot.
Yeah, and
IG-11 or something. Yeah, that's what the BT Tower looks like to me, dude. Like what? Oh man, that's too funny. Look at that. Yeah, crazy. BT stands for British Telecoms. Yes, yeah, I know. They're like the CNN basically, or is it different than the BBC? Is BBC different than BT? I don't know. Oh, it has a spinning restaurant on the top. That is a common thing, actually. A lot of these towers have like these spinning restaurants that you can like, which I think would be hella disorienting. You imagine like eating and like you're just like looking around and like constantly your whole viewpoint is changing. I think I'd get like nauseous. Oh man. Oh cool. I see you're number 58. 58. That's cool, Omega. Washington. Nice. Are you in Washington? Wait, what state are you in? That's just the name of your high school? Let's see. All right. Let me see. We got some screenshots. Okay, cool. Let's kick off the stream, and then I'll talk about my trip and everything. Okay. There we go. Awesome. Okay. Welcome everyone to Office Hours. My name is Dr. Cole. This is Actual Education. Streams helps you out with math homework, science homework, all types of fun stuff. I'm back from a two week break. I was off in a wonderful place called Michigan for an event called Electric Forest. I'll just give you like a quick little rundown of what I did there. This was it. Electric Paradise was the name of it. Let's see. Can I click on stories? Is it gonna make me log into Instagram? I hate when it makes me log into Instagram. Can I please click on this? Jesus, what? Oh, there we go. Okay, cool. Here we go. Yeah, that's a logo I designed or something. I make shirts and whatnot. So these were I made the shirts for our like group and whatnot. And then this was set times. Cool big banner.
Oh, was it like a rave kind of thing?
Yeah, it's a huge rave. It's like 40,000 people in the forest. But this was so what we did was I flew into Chicago. I picked up an RV. And then I had a bunch of other friends from Detroit bring up RVs. And in our little like campsite area, we parked all the RVs to make like a U shape. And then we set up like a stage is what we did.
Damn, okay.
Yeah. So it was a lot of like coordination and whatnot because like we had to they're driving from Detroit, we're driving from Chicago, and you have to all come in together because if you don't, like it messes up the whole thing. So yeah, we did that, and then what we did is after the festival's over, we had a bunch of like special guests that would come by and they would play on our stage, and so we had like the after party, I guess, but this went every single day from like 4 a.m. to 9 a.m. So I didn't really sleep much.
4 a.m. to 9 a.m.
Yeah, it's because the main festival goes from like 3 p.m. to like 3 a.m. and then we had the after party afterwards. It just kept going. Yeah. We probably had like 100 or 200 people like at our stage. Like multiple times we had security telling us that like, yo, you're blocking the road. This is a fire hazard. We need you to stop. So we kept like going out there and bribing them with like water. We're like, here's some water. Like it's a very cool festival. It's my favorite festival. It started raining at one point, so we had to take a canopy over to try and like cover the decks and stuff. And then yeah, it's a very cool time. 6 o'clock in the morning. These are people just like showing up. There's me saying hi to people, and that's me DJing at 7 a.m. That's a special moment. But then yeah, the rain really started coming down, and like luckily we had enough like tarps and everything to like protect all the electronics because this gets like pretty crazy. Yeah, but yeah, that was what I did. That's why I was out for like the last week because I had to recover sleep-wise from that too because I didn't really sleep for like 4 days. He's like, yeah, but I super appreciate Hypatia and Remton, you guys for like running the streams while I was gone. That was really cool, and this was actually a very good first experiment because I've never had anyone else like run things while I'm out. So
yeah, I'm glad it worked out. I think I joined for lesser sessions than I wasn't there every session.
Yeah. All good.
Because I was also kind of in the middle of moving, but then last week I think I joined twice or something.
Oh, awesome. Yeah, I think it's okay. We're always gonna have issues like starting things off, but Hypatia, how did you? It's a learning process, right? I've been doing this for 3 years, so like it's very easy for me to know all the kinks at this point. But I think I saw some of them. It's you got like the chats working and everything, which is very cool.
Yeah, and I guess I think I wasn't able to answer all the question, and I got literally the first question of my first stream. I got it horribly wrong.
It's okay, dude.
I fixed it at the end because it's because I insisted on doing the calculation myself instead of inputting it to say Wolfram Alpha, and then
I see.
Got a totally wrong answer.
Uh-huh.
But later when Ramtin joined me, I think I did. I introduced a lot of the things like logic and mathematical logic, completeness, consistency, and then we also talked about vector bundles.
Ooh, vector bundles. That sounds fun.
Or fiber bundles, and then and then there are some other things, but I guess sometimes I do a really bad job.
No, it's okay, dude. It's okay. The only you know what I used to always say, the only way to get good at something is to be really shitty at it first. Like you have to suck at stuff before you get good at stuff. And the important thing is to try and to like do things. So I appreciate you guys like figuring it out and whatnot. And it's cool because in expanding this right now, right, Hypatia and like writing the grants and everything and whatnot, it can't just be me. Like there's only so much of me, right? So we have to figure out how to get more people on that same wavelength of being able to like connect with students and like and be able to run the stream and whatnot. So that's why this was great. I'm glad we actually did this. It was very cool. Nice. And then maybe, Hypatia, I'm thinking like maybe we can set up like, I don't want you to stop. Like maybe we set up like another day if you want to just do like, I like the like Hypatia hard as fuck math session or something. But like, we'll call something more like friendly, but but basically a very super advanced like, or not super advanced, but like higher level math stream where students can like show up and learn about topics that are beyond them,
I guess right now, if Noise is up to it, I would like to help them to get into a good university because last week sometime they sent out they visited Cambridge, Oxford, so I guess.
And you've sent students to Oxford, like you've helped them get into Oxford, right?
Yeah, I was a part of the team. I guess I help them. I teach them a lot of math, and I help
Awesome.
them with their personal statements and
Mhm.
then stuff like that. And then also the stuff and the math exam. But in terms of interview, that's another person because apparently I really suck at interpersonal.
It's okay. It's okay. Right with it. It's okay. Noise. Oh,
Yeah,
well.
maybe I also would be wanted to like apply. Actually, I'll talk with you later because I
Sure.
wanted to get like a research opportunity, and I thought
Mhm.
that maybe you guys can like introduce me to some people as well that
Sure.
want to do a summer research something
Yeah,
for some
I
experience.
know Hypatia knows a lot of like he knows Hypatia has put me on a lot of email chains with some really cool people that like
Yeah,
are working in that
Yeah,
math
I
circle.
met a lot of laureates before. I guess, well, a
Nobel
lot of
laureates? Well, you come from the pedigree. Your
not
uncle got a MacArthur
Nobel,
award,
but
dog.
Wolf and Abel, they are the big things in math. So
Okay,
there's really no mathematical Nobel, but yeah.
that's cool. That's very cool. Let's see, Noise. Oh, Noise. Yeah, how'd your math exams go, Noise? I know you're studying for them. How'd they go? Let's see. Thanks, Spooderman. Thanks. What a place, bloody pubs. Yeah, dude, Noise almost got like killed like at one of these pubs. I was like, Noise, dude, please stop choosing violence in the morning. I love you, dude. Like, don't die.
What?
He if you read up in commentary, he talks about I think during one of his visits, he was with some girl and these guys started harassing him and the girl and then he stood up for them and basically took on a 1v8, but then ended up like going to the hospital. So
Wait, what? No, you gotta start doing Muay Thai.
you gotta do start Muay Thai or he's gotta start like actually evaluating the odds. I was like, bro, why'd you
Yeah,
take on a 1v8?
yeah, 1v8 might not.
1v8 is the limit, dude. Noise. 1v4. We know Noise can take on a 1v3 or 1v4, but please, the 1v8. We gotta chill on that, dude. He knows the limit.
Yo,
He knows the limit. What's up, yo? Shaq's back from the hospital. I'm glad your surgery went well. How you doing, buddy?
I'm good. I feel taller.
You feel taller? Oh yeah, because you had spinal
Yeah,
surgery, right? You had spinal surgery.
yeah.
Damn, dude. So wait, how can you walk and stuff? What's the rehab for that? Are you like not allowed to
Yeah,
sit for
I
the?
could walk. I mostly sit and lay down. Like I'm like partially on the wheelchair sometimes, or sometimes I have like a walking stick.
A walking
I
stick?
mostly sit down, so like it's all good.
Damn it. You're like getting like the sneak peek of like what being in your 80s is, you know? They were like, "Yo, here's a walking stick, here's a wheelchair." Damn.
Honestly, if you stay in shape, I feel like I've seen like people in their 80s and still be pretty youth.
That's true. Honestly, like I go to the gym and I see some people in their 80s and like they're cranking it out. I'm like, "Good for you, dude. Like, what's your secret?" I want that.
I know some guy. He's like 67, and he like is like a black belt.
Yeah.
He goes to the same gym, dojo that I used to go to.
Nice. Who's how old is Arnold Schwarzenegger actually? Does anyone know how old he is? Arnold Schwarzenegger?
I think he's like
78.
67 or something.
No, dude. No, he's way more than 67. I think he's in his
He's way
70s.
more.
75. He's 75.
Damn.
But like this dude like still goes to the gym and you know, I mean they also take a lot of like growth hormones and stuff, but you know, whatever. It's he still looks pretty good for it's
Actor, but also Californian governor.
governor, politician. Yeah, exactly. This is him at
Yeah,
this is him at Gold's Gym. I used to go to this gym. It used to be down the street from me. And they have these massive, I think they're 330 pound gold dumbbells. They're nuts. But like look at this guy. This guy's 75. He's still like lifting massive things. Very cool. You know what the other cool story that people don't know? He was married to I think Elvis Presley's daughter, right?
No, you married a Kennedy.
Oh, he married a Kennedy. But wait,
Yeah,
who was? Oh, sorry. Michael Jackson was married to Elvis Presley's daughter, I think.
I think so.
Yeah, Lisa Marie Presley is what that was. Yeah, that's crazy. Yeah. The whole like pedigrees of things sometimes in the family trees. Let's see. How did Noyce do in his grades? So further mechanics, I passed by 1 mark. Okay, that's cool. Statistics 1, I failed. Oh no. Overall A, nice. Normal math, 25 out of 30. 14 out of 30. We gotta work on Noise with stats, dude. We gotta help Noise with his stats.
Yeah, no, nice. We gotta
up your stats, dude. You're too smart to be doing bad in stats.
Yeah, I think last time Noise asked the question about statistics and probability. I think like it was quite interesting because the second question, it probably won't make sense if you are a frequentist statistician. I think. Can you find it in the help screenshot?
Let me see where it was. I'm gonna ping Equity. Are you here in the chat? Equity, we're gonna do your question next up, but let's see where he's at. Let me see. Where did Noise, was this the Fourier transform one? Is that the question?
That's before the Fourier transform.
It was before the Fourier transform. Okay. Vector's question, the mining company and whatnot.
After that, I think.
After that, okay. Sorry, we're after.
It's in Noise or Teacup, I think.
Or maybe it was Teacup. Oh yeah. It was Teacup. This was the I know what this question is. This is like the binomial distribution, right? Is that what this is? Or a Poisson? Is it a Poisson?
Yeah.
It's Poisson, right? Yeah, that's a cool one. Yeah, I always forget how these work. It's like it's something like P of, and then it's like the number of like occurrences you want, right? And then like what's like I think like that the average wait time or something, right? Something like that.
Yeah. So it's like it has to be like the occurrences. So it would be, I guess you can put your rate like one bus per 10 minutes.
Sure.
And then what you would do is and then you want to calculate the probability of, I guess it's like a given probability.
Mm-hmm.
No bus has showed up after 6 minutes.
Oh, and then this is conditional, right? This is the the P of A given B, right, is equal to the probability of B given A over, is it the probability of B? Is this what this is?
Yeah, or I think should be like P. Yeah, it's B and A.
B and A. Oh, you're right. It's P B. Yeah. B and A. Okay, something like this.
Yeah, and the interesting thing I was talking about is that this question B, it only makes sense to a Bayesian statistician.
Bayesian. Yeah, right. Exactly. Yeah.
Like, because if it's a frequentist, they're probably going to say you cannot assign a value to a hypothesis or something like that, right?
Yeah, I don't know exactly from that part, but yeah, I know Bayesian is the whole thing. Dog shit distributions. No, dude, you just have to learn Poisson and binomial, dog. There's not many other distributions there. All right, equities here, cool. All right, let me do equities question real quick, and then we'll, and then maybe we'll get into the Laplace. Okay, maybe I'll do the giveaway first, and then we'll start doing Laplace stuff. Okay, cool. All right, equity has question. Evaluate the following functions for the given value. F of blah 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 blah. Oh, this isn't too bad. Equity, you know how to do this stuff. Come on, this is easy mode, right? How do we do this, equity? I know you can tell me, right? Is equity's currently the chess champion? Oh wow, no one's beaten equity in chess yet. Here, let me see. You can come to the stage, equity, if you want, or you can just type. You can type here. Oh, there you go. Equity's up here. What's up, equity?
I'm good. How are you?
Good, dude. How's your summer?
It's been good so far.
Sick. Have you done anything like super awesome yet?
No.
No. What? Okay, here's a good question. What is the best thing that's happened this summer, or the best thing you're looking forward to this summer?
Just trying to start my referee training.
Referee training. Oh, that's cool. For what sport? What sport are you gonna be a ref for?
Soccer.
Soccer. Ooh. That's fun. You get to hand out like the yellow cards and the red cards. I always love it. You just get to throw it at people. Be like, no. No kicking people. Right? It's refereeing is actually a very interesting thing because it's like a whole other dimension to the sport, right? Technically, we could get rid of refs with just AI and camera technology and playback, but sometimes that type of subjectiveness is it's part of the game, right? Trying to make something not look
Yeah.
like a foul, but it is a foul. Yeah, that's cool.
I mean, the question becomes like let's say in soccer, someone tackles someone.
Sure.
At what point do you consider it to be like dangerous enough to give like a red card or like a yellow card?
Right, or whether like the intent is like malicious or whatnot, or you're like, oh, it was an
Yeah.
accident, right? It's like, can a computer really tell whether it's an accident or not?
Yeah, because I think the computer can probably go based on like the speed of the impact,
Sure.
not like how that person was like moving towards the
Yeah.
other person, whether it like looked malicious or something.
But to take into account all the other aspects of like, oh, well, how has this player been playing? Did this other player call his mom like a piece of bricks or something? Like there's probably like a whole other system to it. That's funny. Okay, equity. Let's try to do a question here. It's saying evaluate. Do you know what it means to evaluate the functions for the given value? What does it mean to evaluate?
Would you just substitute like 2 for x, negative 2 for x?
Good. Yeah, you do. Yeah. So what happens when I put that in here for this? What do I get?
8 plus 4.
8 plus 4.
12.
Good. Yeah. So there were a couple steps that happened here. So whenever we put something in here, I always like to like put parentheses around it first. So this is gonna be negative, and then it's comma negative or parentheses -2 cubed plus parentheses -2 squared. Which this right, this becomes what? -2 cubed.
It'd be like negative 8.
Good. Yeah, very good. Yeah. Anytime you have a negative number and it's going to an odd power, this becomes -8. But then there's another negative outside here, so that makes that a +8. And then we have -2 squared, right? This one, a negative times a negative is just positive, right? So that just becomes +4. So this is just +12. That's pretty easy, right?
What's the hotkey for
Yeah.
the arrows?
A. A is the hotkey for arrows. S is to select. L is line, and then F is just draw. Is what it is. Yeah. Okay. Cool. All right. I feel like this isn't too bad. Okay. What if we do? I'm gonna do a fun one for you though. Okay. This is called a composition function. All right. I'm gonna say, what is f of g of -1? Do you know how to do this? The other way they write this is they write this like this. I think. Is this how they write it, Ramton, Hypatia? Is this it? Is it like this?
Yeah.
Yeah. Do you know how to do this, Equity? Have you seen this before?
Yeah.
Okay, cool. How do we do it?
Well, first for the g of x value, if it's like x plus like 2, you substitute x as -1, and then it will give you as 1, and then f, you put whatever you get for the g of x value, you put it into the f of x, and that's your answer.
Nice. Yeah, good. Yeah, good. Yeah, they call these composition functions, but yeah, you got it exactly correct. So what I would do is I put the -1 in first for g of x. So this is -1 minus 3 over -2 plus 1. So yeah, you're right. This is just this is just 4 then, right? -1 minus 3, -4, -4 over -1 is just 4, right? And then once I know that this whole thing is 4, now I plug 4 into here. Right, which is negative. Do you know what 4 cubed is off the top of your head? It's a good one.
16.
Close. That's 4 squared. What's 16 times 4?
4 cubed. Oh, that is 64. My bad.
Yeah, you good. You got it. 64, good. Right, and then that's plus 16. Good. So then this becomes negative. What is that? 48, I think. Yeah, cool. Awesome. All right, nice. Good job, Equity. That's cool. Good question, man. What the fog? so much fog in Canada recently, right? Nice. All right, nice. Mount 1 user equity, good stuff. Okay, cool. We're halfway through. Let me do one of the giveaways. Maybe I'll do another giveaway at the end of the stream. That'd be kind of fun. I'm feeling generous today. Plus, we need more nitro boosts. So if people want nitro and they want to boost the server, that would be dope. All right, cool. Let me see. Let's go to spinner wheel time. Teacup, you want to tell the students that we're gonna do the spinner wheel? Let's see who's here so far. Teacup. Equity. Cool. Yeah, Noise is here. Who else is here? Yeah, in the Twitch. If you're in the Twitch and you want to be a part of the giveaway, let me know if you're here. We'll see who gets it. I'll wait like, let me see. I'll wait like a minute or two. Yeah, you need to be in the Twitch. Yes, good. Thank you, Teacup. Appreciate. Teacup was pretty helpful with you guys, right? During the streams while I was gone. He's super solid.
Yeah,
Yeah,
definitely.
I think,
Awesome.
I think Jacob was like helping out with like setting up the stream and
Awesome. Yeah.
bunch of stuff. Yeah, it was
He's very knowledgeable with Discord and Twitch and everything. Super useful.
That's good. I feel like I'm getting used to like what's it called? Giving or allocating other people to like do stuff as well.
Yeah, delegating. I'm the worst at delegating, but you get better at it.
Yeah, it's so like I realize kids nowadays, like they can teach you as well. So I feel like it's good because someone can do something things like so quickly, and then if they show you, it's like once you save so much time.
Mm-hmm.
Nice to have like a audience who's like handy, because I feel like everyone has to catch up with everything, otherwise you're just gonna get left behind.
Yeah, no, I agree. And actually, I've had I don't know. We had one time I was having like so many issues with Windows stuff happening and whatnot, and I was getting frustrated. I was like, I can't figure this out. The stream's like screwing up. And then Teacup was like, "Oh, just do this and this and this." I was like, "Wait, well, what? How do you know more computer stuff than me, dude? You weren't even born when I was on the computer." But I think also the next generation is super good at being able to Google things. Like, we didn't really grow up with like good search engines per se. So a lot of times I was just like, "Oh, screw it, dude. I'm not gonna be able to find it." But I think the kids these days, because we've had such great, like, even ChatGPT and everything whatnot, they know what to put in for the prompt to figure out what the thing is.
I do a lot of Googling for like my job for a while. And like doing like research or like self-studying. So like now I've also figured out certain ways of like getting around it so like quicker.
Yeah.
But yeah, it's nice to see like people like even it's typical like common tasks people would do it more efficient. So it's like,
You know what I do a lot of times if I'm trying to like get go on, Happy Show. Go on, Happy Show.
So look at the office hours. Like this is some ChatGPT experiment I did last week.
Okay.
Look if you can see what I was trying to do.
What are the first 4 letters in anti-disestablishment? Anti-dis.
Keep reading.
What are you trying to get it to spell something, dude? What?
No, like keep reading. This like it's not about spelling something. Okay. See if you actually spell anything unusual or extraordinary.
I'm looking. What are the 3rd to 6th layer?
okay.
So like just besides the first question,
yes,
ChatGPT got everything wrong, right? Do you see it?
Oh, okay, wait. The first 4 letters in the word are anti. Is that not right?
Yeah.
Oh wait,
That's right.
Okay, but the 5th to 6th.
That's the first one.
Oh, you're so right. Oh wait, no, 5th to 8th. Wait. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it was dis but you said dis e. Is that what you're saying? Is that what we're showing?
Yeah.
Yeah.
And then keep reading below. You can see I can ask the 10th letter or the 3rd to 6th or like things like that. It got it all wrong. And
wait, yeah, why is it getting all that wrong? That's so interesting. What?
Yeah, that's called tokenization.
Tokenization.
That's part of the architecture of the GPT at least ChatGPT's network.
Oh, interesting.
What is it called?
Tokenizer or tokenization. That's the limitation of this particular way of of natural language processing. It's spelled as TOKENIZER. So tokenizer.
Tokenizer.
Yeah.
That's so cool. Wow. I didn't even notice that.
At first I thought that it's gonna get it wrong because it might start from 0. Like,
No, it doesn't do that.
No, it doesn't do that.
yeah,
No. That's
Like,
super
it's not-
interesting. Did you
it's not
know?
a
How did
C
you? How did you?
program.
How did you know about that? How did you know about that? Hypatia?
Well, I mean, I know a lot of linguists who talk about the GPT all the time, or language models all the time. So yeah, I think I just made up this conjectural hypothesis, I
Wow.
tested it, and then
You broke ChatGPT, dude.
well, it's very easy to break ChatGPT.
anti this.
But this way,
I like that.
it's
I like the
not
word
too-
that you used for it. I thought there was a joke with the anti-disestablishmentarianism. I thought you were trying to like mess with it.
It's a long word.
Yeah.
That's the reason. Like, if, for example, if you ask it the last word, it might not be able to give you that either.
All right, that's so interesting. Okay, I think we got everyone. Wait, do I have Teacup in here? Yeah, I do too. Good. Okay. All right, cool. Let's run the spinner. Let's see who wins it, and then we'll go off to the Laplace transforms. Yes, Equity. I love to play another chess game. Challenge me to it. I'll join it. Who's it gonna be? Ooh, Spooderman. Good job, Spooder. Nice job, Spooder. Cool. Good stuff. Awesome. Always love that. Okay, cool. Sweet. We you know, I'll do another giveaway at the end of the stream. End of the stream I'll do another one. So stick around, guys. I'll do another one. Oh bullshit, that's rigged. No, it's rigged if Teacup keeps winning it. When Teacup keeps winning the spinner games, that's when it's rigged. Too funny. All right, let's see. All right, next question. I might need Hypatia and Ramton's help for this one because I forget how Laplace transforms work.
Yeah, I mean, I don't think for this one it really needs to do anything. I think you just have to do the integral.
Okay. Let's say the Laplace distribution is a distribution of the entire real line which has the probability density of that. The variance of this distribution is this integral. Oh, okay, so they already told it to you. Oh, that's nice.
Yeah.
Yeah, and I don't know Laplace or Fourier transform
What?
on the line.
What? Hypatia, how do you not know Fourier? What? You're a math god. How do you not know what a Laplace
I
transform
think
is?
it's more the application for. I mean, maybe the.
Is it mainly it's
transform
only
for-
for physics? I know Fourier, is mainly for like signal analysis and whatnot, right?
Well,
Fourier is a really important person because Fourier transform, its general form, basically has presence in all branches of mathematics. But over the real line, it's very specific but very prevalent in digital signal processing,
Sure.
but it's not really that prevalent in mathematics, I guess. That's the way to put it.
Okay.
Yeah. So, the one of the biggest applications of like Fourier transform is the fact that it can extract essentially the frequencies in your signal.
Which is a real thing, right? It's not like that's not a mathematical concept, right? The frequencies. That's more of like a physics
I mean,
thing.
there's a mathematical part to it, and then it directly translates to having some application.
Okay.
So, yeah.
I see. So that's why, and I get that Hypatia. When you talk about like the real line is very specific to probably just like real world things and whatnot, and in mathematics you're trying to apply it to like everything, right? Even like things that don't have like physical significance.
I think one of the other main applications of the Fourier transform that I know is for solving partial differential equations.
Okay.
So that's another application of it where you see it a lot.
Yeah.
And signal analysis. I think
a lot of signal analysis and also image analysis. Like,
yeah.
Yeah, let me try and do this integral, and then like let's go a little bit into FFTs. FFTs are super cool. I love them actually. They're super dope. I remember we had a bonus question in our quantum grad class to like do this FFT like problem or something. It was like rotating. It was showing how do you rotate an image 45 degrees or an arbitrary angle, using an FFT. And it was like taking the image, throwing it into an FFT, performing some sort of like algorithm that would rotate it a bit, and then inverse transforming back to get the image.
Mm-hmm.
It was very cool. Yeah. But okay, here let me try to do this. Teacup, you here? What's up, Teacup? Hello, teacup. Teacup.
You should look at the thing I sent in chat.
What'd you send in the chat? Would you send it? What the
Look into it.
the fuck you? Oh,
No, the thing
oh,
above
oh,
it.
oh, the ARPM for ChatGPT. Yes. Let me look it up afterwards. Let's do a little bit of math, then we'll go into the fun topics again. But yes, I'll look that up.
Boo, we hate math.
Ah, we
Like,
hate
fun.
math. Okay, this is cool.
It is so fun.
So it's interesting. Evaluating things with absolute values. I don't know. Maybe there's a better strat to this. But anytime I see this is weird, right? Doing integrals with absolute values are kind of ugly, honestly, right?
Yeah.
The way I like to do this is to split this into going on the negative side of values and the positive side of values, but then switching the sign of the thing out front of it. Okay. The way to kind of think is this right, Rampton? So
Yeah, sorry, I don't know if you heard me. So it gives you the same thing because like this is a integral through a symmetric or integral through a symmetric interval.
oh yeah.
And because of the absolute value, this makes it an even function.
You're right. And then the x squared is also even, right?
And then the x squared is even. E to the negative x is also becomes the whole function is even.
Yeah.
And it's also symmetric.
Yeah. Okay.
And then so you can just evaluate it from 0 to infinity.
Yes.
And multiply 2 by it.
Yeah. So here's what he's saying. Teacup is like, so if you have a function that looks like this, do you see how like it's symmetric across here and whatnot?
Yeah.
Okay. Instead of and since the bounds from the integral are from negative infinity to infinity, instead of integrating all the way from here to here, you can just do this and then multiply it by 2. Does that make sense, Teacup?
Yeah. Kind of. Yes.
Kind of, yeah. Yeah, it's just like, yeah, so instead of, usually integrating from negative infinity to infinity, I'd have to start at negative infinity and do this integral all the way to positive infinity. But if I know going from negative infinity to 0, the area under here is going to be the exact same as the area from 0 to positive infinity, I just need to do it from 0 to positive infinity and then multiply by 2. That's the trick here. If this wasn't an even function, for instance, here's the classic example. Let's say I had like the integral from negative infinity to infinity of let's say absolute value of x over x, right? Okay.
Yeah.
This is not symmetric. I mean, absolute value of x is, okay, but then dividing by x is going to like screw things up. What this actually ends up looking like, this ends up looking like, I think like this is what it does, right?
I'm not a fan of that.
It's a weird one. It's a weird one. But the cool way to look at this is to think of this as, okay, I can split this into 2 integrals. I can do this as the integral from negative infinity to 0 plus the integral from 0 to positive infinity. This is an important. It's an important thing in integrals. If you have like a function and you're going from like, let's say here, like from A to C, you can also split this into going from A to B and then going from B to C and then add the 2 integrals up together.
Let me interject another thing. Is that discontinuity can destroy integrability, at least Riemann integrability.
Okay.
Like, so look at here, you have only one point that is discontinuous.
Yeah, x equals 0, right?
So here, you can actually, like there is a sensible way of assigning a value to this integral.
Mm-hmm.
But what if there are the points at which the function is discontinuous is dense on the entire real line?
I see. Such that there's just not one area. Yeah, right.
That makes Riemann integral you can basically assign any value to the Riemann integral of that function.
Yeah.
And one example of such function is called Dirichlet function.
Oh, Dirichlet. Yeah. Dirichlet and what's the other one? The boundaries. You know what I'm talking about? Dirichlet boundaries, something boundaries.
I think the Dirichlet functions are a little bit different. But
Oh,
yeah,
are they?
I think for the one you're thinking is the boundary values, which is the Dirichlet and the von Neumann.
Von Neumann. That's it. Okay, sorry. Yeah. But that's different than the Dirichlet function.
Yeah, I forgot what Dirichlet function. I still saw it in ENN. before. I don't know if
And even further point is that although Riemann integral, by which you cut up the domain of the function,
Mhm.
you instead cut up the codomain of the function. That's called the Lebesgue integral, which can actually be evaluated on the Dirichlet
Oh, I see.
function.
Okay. You're kind of like cutting out the. I feel like we're kind of doing that here. We're kind of like. Luckily, there's only one point where this is discontinuous. Teacup, do you understand what we talk about when we say discontinuous?
Yes.
What is this? Why is it discontinuous at x equals 0? Why is it discontinuous here?
Because there's a gap.
Good. There's a gap. Yeah, there's a big gap. Yeah, and the main reason being here is if you plug in 0 into here for x, you get 0 over 0, which is undefined. Like we don't know what 0 over 0 is. It's not a real thing.
If you put in 0.01, then it's not defined.
Good. Yeah. So you'll see here. So here's usually my trick. If we have an absolute value function, what I like to do is to break the integral up into where it is positive and where it is negative, okay? Here, that happens when x is equal to 0. If I had, for instance, x minus 3, that would happen at x equals 3. That's when I would, like, split something from, like, a to 3 and then from 3 to something else, okay? But here it happens at 0, okay? And what I say is that, okay, but so if I wanted to express what this is without having the absolute value, right? Because if I put a negative number into here, right? What does the absolute value do to it?
It makes it. Wait, what'd you say? If it's a negative, it becomes positive.
Makes it positive. Good. Right. So instead of writing absolute value of x here, I'm going to write negative x on the top. Because I know that my x values are already negative, but I need them to become positive. And the way to do that is to put a minus in front of it, because the negative of a negative will make it positive.
Yeah.
Good. And then so this I'm going to leave as just x, okay? And then so for here, for 0 to infinity, these are now positive values, right? If this is positive, absolute value is still just going to make it positive. So I can leave this as x over x. Do you see how I split this? This is a very important thing to kind of know how to do. What we're doing is we're representing this absolute value as negative x because I know the values of x that are going to be put in are only negative values. And camera, don't do that to me, girl. One sec. Windows. Wait, where'd my mouse go? Oh god. Yeah. One sec. My everything on mine froze too. One sec.
Hello.
Yeah. I can hear. Can you hear me?
Oh.
No. One
I
sec.
think gold might have.
Oh, just gold.
Yeah. One sec.
Yeah. I think some of you should add them.
Gold, wake up.
Do you guys
Absolute man.
are you guys still see the stream working, or is the stream frozen as well?
The Twitch stream is frozen.
Like,
He's gone.
Look at the left side. The chat just updated.
There we go.
Let me
There we go.
erase
There you go.
something.
My video's
His
working
stream
at
is
least.
back.
Is the audio working or no?
Yeah, but the
But-
voice is not, I think.
There you go. Is it working now? Working now?
Yeah, it is.
Dude, I don't know why. Like, dude, sometimes Windows just decides to like shit bricks on my USB controller, and then like everything just. The problem is,
You should go all in Linux. Then.
no, dude, none of the video games work on Linux. Though. That's the problem. Yeah. Give me a second.
Stream
Well,
do the
today-
cloud gaming.
Today is not Fortnite day. Today is Population 1 day.
We do need to play Population 1 together. One sec, and I gotta change my levels here. No, levels are okay. Okay, cool. All right. Anyways, all right. Back to. It's weird because it was showing mic output for me, but it wasn't coming up for you guys. I guess, right? That's so weird. Okay, whatever. All right. Anyways, all right. Teacup, do you get this? Do you get how, like, for instance, like, because how I write absolute value of x is negative x and here I write as positive x here?
Yes.
Cool. All right. What is negative x over x?
Negative x over x would just be negative x, I think.
No, not just negative x. What's negative x over x? You got it.
Hey Siri, what's negative x over x?
I know you got it. No, come on, come on. Wait, okay, what's x over x? What's that? How do I simplify x over
x?
Yeah, what's x over x? You got it. What's 3 over 3?
I don't know. I think it's 5,000.
No.
It's 5,000 gold. It's the other way.
You got it. Come on, you got it. I know you got it.
So is it negative 1 and 1?
Yes. Yes. This is the integral from negative infinity to 0 of negative 1. And this is the integral from 0 to infinity of just 1. And sorry, I forgot my dx's here. Whatever. Okay.
Nah.
Right. Okay, cool. And then what's the integral of just negative 1?
The integral is negative 1.
Yeah, what's the integral of just like a constant dx? Do you remember this? This is the same thing as like something times x to the 0 dx.
Isn't it like so it would be negative 1 x plus d, I don't know.
Plus c, yeah. So remember what we do is we raise the power by 1.
Oh, I said
and then we divide by 1, right? So this becomes just equal to ax is what it does. Because you raise this to 1, you divide by 1. Cool? All right, good. All right, so here, yes, this becomes the integral of negative x from negative infinity to 0. And then this just becomes the integral of x from 0 to infinity. Okay? All right, and then do you remember what you do with these? What do we do with these endpoints? I know you remember. Yeah, can you hear me? You can hear me, right? Yeah? Yeah, my mic should be working. Oh, now it's your headset, so it's not my headset. Teacup, teacup, teacup. Mr. Bean's gonna come out. I do this because then, like, Teacup will hear the music of something playing when he gets his headset working. Bum, 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 bum.
hello there.
See, there we go. What's up? You got your headset working again?
Yes, hello,
Okay.
hi.
All right. What do we do with this? What do we do with the endpoints here?
I have no idea.
Okay, good to remember. So what we do is we take, so these are called the bounds of an integral, and I put them here. And what I do is I put this one into here, and then I subtract it from putting this one into here. Okay? So this becomes negative 0 minus, and this is where it gets weird. There's so many negatives here, right? It's minus negative infinity, right?
I think it's stream float on my end.
Well, so right now you probably should not split it in this way because, like, the result will be telling you like.
Yes, I
negative
know. It's gonna say negative infinity plus positive infinity.
which does not
I know.
rigorously speaking
That
make
means
sense.
Yes, I know. Hypatia is technically correct, like from the math. Like I'm like sweeping things under the rug because like technically we're not allowed to say that negative infinity plus infinity is equal to 0. But in this case, if it's negative x plus x, that is just 0. it's literally the same thing. Yes. I am cheating. I'm cheating a little bit. This is dirty math. This is.
Because the only like you can do what you want to do is instead of infinity write like b.
Yes, and then say the
you
limit
take
as
the
b. Yeah. Okay. Yeah. Let's be rigorous. Let's be rigorous. I'm fine with it.
The only reason, like from this standpoint, like I mean, you could always the reason you don't want to do it is because the infinity could have a size as well, right?
Sure.
Like we can see that
Yeah,
both of
that's
these
what
infinities come
I
from.
wanted to say, like, if you insist on doing it this way, you can do it with ordinals.
Ordinals. Ooh, okay. There's a term I haven't heard in a while. Okay, this is what it. Okay, if what we're gonna say here to be mathematically correct is I'm gonna say the limit as b approaches infinity, and then I'm gonna substitute the infinity with a b. is what it is. They are so right, because the problem is, Teacup, if I, for instance, had x squared minus x, and then this was like infinity squared minus infinity. Infinity squared is just infinity, and infinity minus infinity, that's like not defined. You can't do that. It's not, because there are different sizes of infinity. It's weird. Yeah. But this is what's going to happen. Minus minus plus minus. Minus b plus b equals 0. So your answer is just going to be 0. And that's where that comes from.
So basically, ordinals are like, well, if you want, so like all the limits when you have like you have a quotient, you have a ratio, or things like that, you can all somehow do it with ordinals. So like ordinals and cardinals are the things like beyond like things that extend natural numbers.
Okay. Okay.
So ordinals like omega or omega squared, or
Oh.
and cardinals like aleph naught, aleph 1.
Okay.
Things like that.
This kind of reminds me of like in computer algorithms when we have, do you know like big O notation, right? Big O like n squared or something. You seen this before?
Yeah, to discard the constant coefficient or something.
Is that an
like
ordinal? Is that an ordinal?
No, that's not. That's just
I tried.
It's an informal notation to record a polynomial.
Okay. Okay.
A class of polynomial.
Class of polynomial. Yeah, what the order is. All right. Cool. All right. Well, so we didn't actually do this integral, which this is going to end up being integration by parts, which is a whole other question. But I think it was important, Teacup, for you to see how to do this, right? Because I think this was kind of more like obviously we need to refresh on how to do integrals first, and then I think maybe next time I can teach you how to do integration by parts for this, right? Is that cool, Teacup? I feel like it was better for us to like go through making sure you understand how to split an integral into 2 parts, and then how to like actually do an integral. What's up? Indeed. Well, no, this is good, because sometimes I want you guys to ask like big questions and whatnot, and then that's a good starting point to try to bite off more than you can chew, and then we can figure out, okay, but wait. Let's make sure you understand the building blocks of how to get there first. Otherwise, you just get lost. I remember going to certain classes or conferences are a big one for this. If you go to a conference sometimes and it's very specialized in some field, and then they just start like throwing out all the jargon and all the specialized terms, and I'm just like, I'm going to sleep because I don't understand any of this. It's important for us to make sure you understand the basic stuff first. Yeah. Noise says his question is quite tame. Oh, is it? Okay. Is this yours? Noise? Is this your question, Noise? I think it is. Let's see. Dun, dun. Cool. Yeah, and then we got Ethan. Awesome. Okay, cool. We're rocking around. What's up, Riplaw? Good to see you, Rocky. Haven't seen you in a while, dude. Or I mean, you probably haven't seen me in a while. I've been gone for 2 weeks. I apologize. Had to go off and help out my Wook people. Oh wait, where'd that go?
Oh, sorry.
Oh, you're good. You're good. I was like, who's moving the screen? You're good. All right. A scientist is investigating the concentration of antibodies in the bloodstream. The concentration of antibodies is measured in milligrams. Is this? Oh, is it a differential equation? That's pretty cool. I didn't know that it actually was. I guess it's a flow problem, right?
Yeah.
Find a general solution. Oh, this is cool. Noise says this is a quite tame question. Yeah. So okay, this is a good thing, because a lot of students always wonder, right? Especially the pre-med students. They're like, why do I need to know this level of math? Like, why do I need to do this? This is when am I ever going to do this? And this is a good example of when you could, right? Differential equations are very cool for modeling. We went over this last time, like predator-prey models, all types of cool stuff. But okay, the reason why it's called a differential equation is that I have, for instance, this is this variable x, and I have various orders of derivatives. So I have the first derivative here, I have the second derivative here, and this is what we call like the 0th derivative. All right, to do this one, correct me if I'm wrong. Is it just the e to the x trick? Is that what this is?
Yeah, e to the. I guess it would be lambda t. I guess.
E to the lambda t. Is that what we say? Yeah.
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 Or
So,
I'm here also if you want me to do it.
yeah. You do it. Here, you explain this one. That's good. I
Yeah.
like to learn a little bit.
All right. Yeah. So for for differential equations, I guess for people who are not familiar with what differential equations are, anything that has any equation, so called a differential equation, because you have first an equation, there are numbers there,
Mhm.
and two, differential means derivatives. So you can see a derivative of x in here, and then another second derivative of x. Wait, why are the lines so
Yeah.
off?
They should be here and here, right? It's okay.
Wait,
I'll move them.
it's so weird for me. Once.
Oh yeah, try. You can also try refreshing the webpage sometimes. Sometimes that screws up. Yo, what's up, Habib? The 5 gifted subs, Habibs. Good to see you, Habibs. I'm doing great, dude. Thanks, man.
I might be using a second screen, and this is just messing the whole thing up.
Oh, is it not coming up on? Oh, okay. Do you have a tablet? Is that what you have?
Yeah.
Make sure. So with my.
No, like it looks fine on my screen, but like on your screen,
Oh.
it looks completely different.
Try logging in and out of the whiteboard again. That sometimes screws up.
Yeah, I tried that again, but like.
Oh, this is still off?
Yeah, it doesn't matter.
Okay.
But we have the derivative in here. You've underlined it.
Good.
And so this is why we call this a differential equation. Now, this is called a second order differential equation because you have the second derivative of your function in here. So first thing is, what's your function? Your function is x, and then the variable that is in terms of it is t. So like usually we see like f of x, right? F of x, essentially you have f, which is your function, and x is your independent variable. That's what we call it. But with this one, x is your function, which could be a little bit confusing, but then t is your independent variable. Okay, so you can kind of think of it as like this is equivalent to your f, and this is equivalent to your x. Okay, so now to solve this, the you have to guess pretty much for second order differential equations because they're a little bit harder to like deal with. So what you'll end up doing is you guess an answer that has the form e to the lambda t as your solution for x. So you say my function has this thing. Now, when you're doing this, first thing you want to do is you want to solve this when when you have a homogeneous equation. Homogeneous means on the right hand side instead of 26, you have 0.
Mm-hmm.
So imagine your equation is 100 d squared x dt squared plus 60 dx dt plus 13x equals to 0. So this is what we're going to find the solution to by doing this. Now, the 20, everything 0 can just always be added to whatever is on the right hand side. So this can be like 0 plus 26. But for now, we're just going to only solve the first part where what is the solution to this problem if x was if this was equals to 0. And so once you put this in, you would get 13 lambda x. So let's think what happens if I take the derivative of x with respect to t. I'm essentially taking the derivative of e to the lambda t, which means that this is the derivative of the exponential. So if the lambda comes down, you get e to the lambda t again. And then if you were to take the derivative of this again, which is the second derivative, you would get another lambda down. So you would get lambda squared times e to the lambda t.
Yeah, you just keep pulling down lambdas. So important for you guys to remember that, right? The derivative of e to the x, ddx, is just e to the x. But what Ramton's doing is called a chain rule, where if this is not just x, say this is like a times x, then this also pulls down the constant in front of it. just to make sure people. Some people have seen it more, I guess, that way. But yeah, keep going, Rampton. You're good.
That's good thing. I should have mentioned that.
Mhm.
But yeah, okay. So then you can rewrite this equation. So you get 100 lambda squared e to the lambda t plus 60 lambda e to the lambda t plus 13 e to the lambda t equals to 0. Then what you could do is you factor out this e to the lambda t from the whole equation. So I have e to the lambda t times 100 lambda squared plus 60 lambda plus 13 equals to 0. Now you are left with a multiplication of two things that gives you 0. So it means that either this one's 0 or this one. Now, because an exponential can never be 0, it means that the second one, this can't be 0. So this is the one that has to be 0 between the two of them. So you will get 100 lambda squared plus 60 lambda plus 13 equals to 0. And now you just have to solve this equation, right? Which you can use.
Yeah, what type of equation does this look like, right? Yeah.
Yeah, this is a quadratic equation, so you can use the quadratic formula for it. And I think hopefully the answers are not going to be like disgusting.
60 in that 13 is ugly. What?
Yeah. And yeah, maybe I'll just find the solutions in Wolfram Alpha.
Yeah, just
because doing a quadratic formula with this is just okay. So you find the answers to this are this doesn't even have real solution.
No, there's no real solution. Oh, so it's imaginary?
Oh, okay, yeah. I'll see. Ooh, this is actually important.
Yes, right, because this means it's a wave or something, right? Or it propagates.
Sinusoidal, yeah.
Sinusoidal. Yeah, this is cool. This is very cool.
So the solutions to this, I'm gonna scroll down. So you get lambda to be negative 3/10 minus where is it? Sorry. Minus I/5. I'm just gonna write this as negative 3 plus 2i/10, just so that because the way Wolfram is giving me the answers. Okay, the other one is the plus I. So then we go, this is lambda 1, lambda 2 is going to be negative 3 minus 2i/10. Actually, I should write them separately. It's better because it's going to look, we're going to separate them anyways.
Right. So this is gonna be really cool.
Okay. I'll keep it like this. And then this one is going to be negative 3/10 plus I/5. Is that the correct one? Yeah. Okay. So for those of you who don't know, I is the square root of -1.
Mm-hmm.
How we end up with here is, let's do the quadratic formula. So we already have the answer. So the quadratic formula gives us lambda is minus b, so minus 60. This is your a. This is your b. This is your c. So minus b plus minus square root of b squared, which is going to be 3600, minus 4ac, 4 times 10 times 13, divided by 2a, so 200. Now, if I do this, this is actually not that terrible. I can do this in it's
it's 5200.
Yeah, so this is minus 5200.
So 1600.
So,
this is nice.
Yeah, so the entirety under the square root, we have minus 1600. So now here's where we can learn a little bit about I. So you can say that this is the same thing as the square root of 1600 times the square root of -1. Now the square root of 1600 is 400, and the square root of -1 is I. So that's how we can end up with lambda being minus 60 plus minus 400i
Mm-hmm.
divided by 200, which gives us these values.
Right, because everything's divisible by like 20 at this point, which is nice.
Yeah, everything's divisible by 20. Exactly. And so these are the two values we get for lambda. Now,
Mhm.
the cool thing is, so let's look at what happens if I come in here and I want to write the solution. So my solution, actually, when you have a second degree differential equation, you would have two solutions to this.
Mm-hmm.
So the first solution is e to the lambda 1t, and the second solution is e to the lambda 2t.
And do these happen at the same time? Like, can you say the solution is e to lambda 1t plus e to lambda 2t? I forget.
Yeah, it's like any variable times that.
Gotcha.
Right?
Right.
And I'll show that also, like, briefly, as to why that would make sense.
Mm-hmm.
So e to the lambda 1t is e to the negative 3 over 10 minus I over 5. Now, this whole thing is just t. Now, I'll split this into two parts. There is e to the negative 3 over 10t times e to the negative I over 5t.
Mm-hmm.
Now, this is a good time that we can introduce another identity, which is called the Euler's identity. So if you have e to the power of I times theta, where theta is just some number that is being multiplied to this,
Yep.
this is equals to cos theta plus I sine theta.
Mm-hmm.
So somehow you're going from an exponential to these sinusoidal functions, like things that are periodic. Now, the magic of this is actually because of the I in here. Now, the proof for this, we need to know, what's it called? We need to know Taylor expansion.
Sure.
Which, we'll go through it at some point, because I don't want to like keep opening.
Hey, we can keep opening doors. We can keep opening doors and going down hallways. That's the beauty of math.
So we'll keep that one for later. But then it's e to the I theta that I have in here. So this means that the first part is like this. The second part looks like e to the negative 1 over 5 times it. Or in other words, this will look like cosine of negative 5.
Negative 1/5.
Negative t over 5.
Good.
Plus I times sine of negative t over 5.
Mm-hmm.
And because the sine of a negative angle is the negative of the sine of this, you can write it's the cosine. And the cosine of a negative angle is the same as the cosine of the positive. So you can write this as cosine of t over 5 minus I sine of t over 5.
Very cool, yeah.
Yeah, a lot of the times they write the formula that, if this is positive, then you have the positive in between them. If it's negative, it's the negative in between them.
Right.
But it's technically always the positive between them. But then when you have a negative, it makes your angle negative.
Right.
And negative angles for a cosine doesn't matter, because your cosine is going to be the same for a negative angle. And for a sine, it's the negative value for a sine. So that's where that comes from as well. Yeah, exactly. Because of those graphs, and you can see. So yeah, once you have a negative of something, for cosine, it's the same, and for sine, the negative of some angle is equals to the negative of the sine.
Yeah.
Which Gold is showing on the graph. This is a good explanation, like visually, as well.
Yeah, I think a lot of people when they see this like odd and even for cosine and sine, like they have like no clue. But once you show them visually, you're like, oh, if I go this way or this way, it's the same value. Versus
I'll show it also on like
the unit circle too also works, yeah.
the unit circle as well. So you can kind of think of it this way. If let's say you have some angle here, theta, and this becomes negative theta because it's going the opposite direction, I have to try to draw circle and lines.
You can do this. You can do this. There's there.
Yeah.
And then what
And
you need? Oh, here. Let me try to like get the line for you. Yeah, that looks better.
Okay, there we go. Okay, and then this is some angle here, some angle here. So with this one, you have the positive theta. This one, you have the negative theta. Now, if you look at the x values associated with these, it's the same value. They both have the same x value. If I were to like show what is the x value of this graph, it's just, or I mean, this is better. They both have the same x value.
Mm-hmm.
What about their y values? Well, because of the symmetry, whatever the y value of this is for that, the y value of this is the opposite of that. So that's what this is. The x values is the sine, or sorry, is the cosine. So your cosine of theta is equals to cosine of minus theta,
Mm-hmm.
and the sine of theta is equals to, or sorry, sine of minus theta
Is
equals
negative
to
sine of
theta
theta.
of theta.
Yeah. Yeah.
So-
Math textbooks will always just write it out like this, and kids never really understand that. So this is why I just draw this for them.
Graphically is a lot better.
Graphically makes a lot more sense.
Yeah. So just to we can kind of I'll try to wrap it up here.
Yeah, let's close that door and come back out to the hallway.
So essentially we get two solutions. I'll talk about the one solution right now. Like we have the two solutions. I'll show why both solutions simultaneously exist. Like unless we can go longer for the stream or something.
Yeah, you can go. You can go. I'm fine. I'm not doing anything.
But for now, the important thing is this means that your solution, there is an exponential part, and then there is the sinusoidal part. Now, well, the I part doesn't really matter. It's the cosine part that ends up mattering, right? But essentially, it's just some kind of a wave that happens. So if you were to actually draw this will look kind of cool. So I'll just draw it on the bottom.
Mm-hmm.
So let's say you have this graph, and this is the, let's say, exponential decay for e to the negative 3/10.
Oh, okay.
Is that what it was? Yeah.
Yeah,
E
it's
to the
3/10.
3/10t. And then this one is the negative e to the negative 3/10. Okay, so it's the upper part and the lower part, and like this is the reflection of the upper part essentially.
Mm-hmm.
And then your solution ends up looking like this. It's like a wave that stays in this pocket.
Yeah.
So you can kind of see that this actually makes sense because your body actually now.
Yeah, so let's go back to what the actual question was, right? We were dealing with, what was it? It was a vaccine, right? Antibodies in a vaccine or something?
Yeah, antibodies in a vaccine.
Yeah.
So one of the things that there is, for anyone who's interested in biology, there's a thing called the homeostasis.
Yeah.
Homeostasis, yeah. So homeostasis is your body's ability to want to readjust itself to its previous state.
Like steady
So, for
state. It
example-
wants to be like stable.
Yeah, exactly. So it wants to create that stability. So what happens is that initially your let's say antibodies might get like a spike or they might have a huge drop, right? And if there's a huge spike, your body tries to counter that, so it brings it back down.
Mm-hmm.
And then when it goes too down, then once again they're kicking in, so it goes back up. And then this kind of effect keeps going back and forth, and your body as it what's it called, fights with these uh, like vaccine, which are like the could be the weaker part of this is probably going to be for the virus type that everyone's getting like the weakened version of the virus.
Yep.
So your body is constantly falling sick, then fights it, then it goes into a sick mode again, then fights it again, and then eventually your body adapts. It builds those antibodies, and now it's at a point where it comes to a halt where now it's like, oh, okay, I'm good. I figured it out.
Right.
Now I have
It's being
antibodies
level.
required
Yeah. This
to
is
fight.
this is what we call like overcorrecting, is what it is.
Yeah.
I think the one thing that might make sense to the kids is like if you ever played like a racing game or something and you notice that like if you turn really too far to the right, you'll try to turn really far to the left to get back to the center, but then you'll overshoot it, and then you have to readjust to that. But every time you're going back and forth, you're eventually gonna like get back to what the center was.
Yeah.
Yeah. Don't worry, Ethan. We are gonna do your question. We're almost done with this one.
Yeah. But yeah, so I'll finish the second part so we can do Ethan's question.
Yeah.
But one thing I will later justify, maybe if we have time at a different point, I'll talk about Taylor expansions.
Yeah. The Taylor
which
expansion should be cool.
understands why e to the I theta is like this weird thing.
Mm-hmm.
You get some cosines and I times sine stuff.
Uh-huh.
The other part is also why your solution will essentially look like c e to the negative or 3 over 10, or sorry,
It's
it
e to the
looks
negative 3 over
like
10 all outside everything, right? And then there's different
3 over
coefficients on the
10t times c1 cos 5t plus c2 sine, or sorry, 1 over 5.
and one's cosine, one's sine.
Yeah.
Okay.
And essentially, it's because the imaginary part is also another solution, but unless you're looking for imaginary part, you can drop the imaginary part as well.
Okay.
But they're gonna have like a phase shift essentially.
Oh, I
Right.
see.
Yeah, but yeah, that's your general solution would look like pretty much.
Okay.
And then this is remember the whole thing. This is when it's equals to 0. So this is what we call the homogeneous solution.
Uh-huh.
So this is your homogeneous solution. You still have to
Oh, you have to
solve
account for the
for
20. Sorry, you have to account for the 26.
26, yeah, which is
Oh.
going to be the particular solution now, or whatever is on the other side. Now, because this is easy, all you have to know is that, okay, well, how can we get a 26 on the other side?
Uh-huh.
Well, it doesn't. If x is some kind of a constant,
Yeah.
then it can give us a constant on the other side because the derivative would go to 0.
Yep.
Second derivative would go to 0.
Mhm.
So x equals to 2 is going to be the other solution because 13 times 2 gives us 26.
Oh,
So your total
okay.
solution
Is it's the cosines and then it's plus 2.
Yeah, exactly. It's e to the 3 over 10t times c1 cos t over 5 plus c2 sine t over 5 plus 2.
Yeah, there you go. Yeah, cool. Nice. Good question, Noise. Awesome explanation, Ramton. I like that. It's very thorough. Like we went through like a lot of different parts of this. You basically gave like a crash course in DiffyQ, which is cool.
Yeah, like and the thing is, like, I feel like one of the biggest things that is interesting about this problem is how your body actually adapts to things. Like your body is always has this homeostasis thing, and everything that happens in body, it actually happens in this sort of like oscillatory manner. Like
Yeah.
when it comes to I don't know who's interested in biology, but if you have like those receptors that you have they call it the Mg and Na, like the magnesium and the sodium, uh, that happens in neurons, that they kind of balance out their levels like inside the axons and outside of the axons. Those
Mhm.
happen periodically. Uh, if your heart ever goes out of rhythm, it readjusts itself. So uh, once again, that also happens periodically, and there are ways that these things could become catastrophic, and that's where we can get into like non bifurcations essentially.
Yeah, yeah,
It
exactly. Like breaking points and stuff.
becomes really like it becomes more advanced, but that once you understand all of these things, then you can understand bifurcations, and essentially um, bifurcations when they happen one of the examples of it is heart arrhythmia,
Hmm.
and essentially your heart goes out of rhythm, but then instead of fixing it itself, it ends up amplifying the bad effect, and
Ah,
this happens under certain effects.
it's a negative
And so
feedback cycle.
sorry.
It's like a negative feedback loop.
Yeah. And then that's what heart arrhythmia happens. It could also happen in like airplanes. Like sometimes the airplane wings, when they swing a little bit, they stop swinging. They kind of balance themselves out. But if they end up wobbling too much, then they end up going out of wobble even more, and then the whole wing falls off.
Yeah,
So it's
yeah.
this
That's
is
also
something
like
that
the,
you
the
can,
the swinging bridge and everything. There's a
yeah,
whole thing to it.
exactly.
Yeah, that's cool.
So yeah, those are some further, I guess.
There are
Like,
a lot of practical applications to this. And, that's cool. I really appreciate that. Like for people to see that, like, math is not just like just doing a bunch of numbers and stuff. There's a lot of practical shit to this. Like, we do this because it explains the real world.
yeah.
Very cool. All right, Ethan, you still here? Last question of the day. Where's Ethan? What's up, Ethan? I know he was in the chat at one point. Biology is a social science. Yeah. You know what I used to say? I used to say it's a soft science. My ex used to get so mad when I would call. She got a psychology degree. I'd be like, well, the soft sciences. She's like, what do you mean soft science? I'm like, it's literally called a soft science. Ethan says, hold on. Okay, cool. I know. It's just like, maybe she was a little soft. What was it? Okay. Yeah. What was it? Soft science versus hard science. Because then people are like, oh, hard science is difficult. Yeah. Hard sciences use math explicitly. Ooh, that's cool. Soft science use the process of collecting empirical data to use the best methods possibly to analyze. That's cool. Yeah. So probably like even this analysis of this vaccine, like, it doesn't strictly follow this mathematical model and equation, but it it's close enough. It's the data we've gathered makes it general. The intellectual domain, dude. What is this, bro? I love Quora, dude. Quora. What's up, Ethan? How's your mic? Is your mic okay? Your mic. I hear a little bit of myself in it. Ouch. I hear myself a lot in it. Dude, look at this noise, dude. Look at this. What was it? Oh, this is too funny. I love when people do this. Okay, can I go to the next slide? Nothing against biology. Like, biology's cool, but like it's just kind of funny. I want to see where was this slide I wanted, dude? Hard science, measurement, soft science. What do you think? Disapprove, approve, measurement. I don't know. 4. That's too fun. Psychology is fairly interesting. I agree. Psychology is fairly interesting. It is cool. Yeah, I'm not talking shit on psychology. It's just yeah. It goes through my head before making questionable decisions. Yeah, like taking on 8 people at a pub. Yeah, noise. I imagine there's this movie called I think is it Good Will Hunting? Is that it? Where he's doing like game theory in the bar or something.
Yeah.
Is that it? Yeah, he's like talking about like how to get the girls and whatnot. I feel like this was Noyce, like having the equations going on in his head in the bar, but then he's like, how do I take on these 8 guys? I didn't really want to take on 8 people. I was just I was nice about it. I thought you told them to like shut the fuck up. Yeah. They're not gonna be nice about that. I didn't fight back. Okay. Well, I mean, it's okay. Ethan, what's up? Is your mic fixed? What's up, Ethan? Ethan? Still can't hear you yet.
Hello, can you hear me?
Yeah, I can hear you. What's up, dude?
Is my mic fine now?
Yeah, your mic's better now. You're good.
Okay.
Awesome. Okay, here we go. Oh, we're talking about a dragster. This is cool. Like a drag car. You know what a dragster is?
Hello. Sorry. Well, no, I don't. I don't
Okay.
know what a dragster is.
A dragster is like a racing car or something. That's or a drag racer. I don't know. Like if I type in drag star, I'm probably gonna get something different. But like one of these. This is it. Yeah, these things are cool. They go like super fast, like really fast race cars. Maybe they don't have these in Belize, but they do in like certain parts of South, United States. They love this stuff. Anyways, so yeah, this is a very fast car, is what it is. Okay, and they're saying it accelerates to a speed of 112 meters per second over a distance of 398 meters. Determine the acceleration, assuming that it's uniform, of the dragster. These are cool. This is physics. Are you going into physics, or you want to learn more about physics? I think, Ethan, right?
Yeah, I am going into physics.
Okay.
You know, I heard that the physics teacher is like a Chinese person.
That's cool. There's a lot of Chinese people in Belize, I think, right? There are a lot of Chinese investment comes into Belize, so that would make sense.
Yeah, there's Chinese shows about it, so yeah.
I think they were literally giving out Belizean passports to Chinese nationals if they like gave enough money. I remember when I went to Belize, I visited Belize at some point, and I noticed there was a lot of Chinese influence, and I think it's because they invest a lot of money there. It's cool.
Yeah, but the thing is that our government is so horrible.
I
Like,
know.
use
Why are they
money-
doing a Hypatia? Why give us a little bit of the backstory? Why is China investing in Belize so much?
Like they plan proxies into foreign countries. For example, right now Pakistan is entirely their puppet.
Oh, really? I didn't know that.
Yeah, and then for whatever they are doing, for example, to the US, they do it in more horrible ways.
I know.
Like they use psychotropic substances to control vulnerable people to
Oh dear.
become their proxies.
Well, that's not good. We should be
Yeah.
poisoning people. That's like mind control stuff. Let's not do that.
Yeah, like they sell fentanyl to
Wow.
people who are vulnerable and use that to turn them into agents of their own or things like that.
Bro, this is like a spy movie or something, dude. What? What?
Yeah, like China has so many human rights violations.
Yeah,
Only domestically, but
we could go into the whole thing about like Cuba, right? Wasn't there something where like a bunch of people's at the U.S. embassy in Cuba were like getting these diseases like because of the sound waves being like shot at them or something? Look it up or something. Look up like it's like Cuba like noise something, U.S. embassy, and I think they thought it was the Chinese doing it to them. It's kind of interesting.
Oh, yeah, that's the sonic weapon. Like
Sonic
it makes
weapons.
people, like it just try to make people unconscious, or at least make them feel really uncomfortable.
Yeah, crazy stuff. But okay, Ethan, your physics teacher's Chinese. Hopefully, they're not an agent of the evil government of the Chinese Communist Party. But it's okay.
They said that he was like a nice teacher that can give easy grades. Like when I take down notes, he'll give you like 100.
Okay, well, it's important to learn things. You know, getting good grades is good. Well, but like
this
it's
is
important to
not
learn things.
Tell you to prejudice anyone. But
Yeah, no
just,
prejudice. Just watch out.
Like it's just a fact, and if you actually see the Communist Party's presence, don't agree with them. Do not like do what they ask you to do.
There you go. Be a free thinker.
On the other hand, there are a lot of people who are with us. There are a lot of people who hate them too.
Yeah.
Like me. So like you don't inflict the rage upon them to every person.
Yes.
Of Chinese
This is a key thing about like racism, I guess, and whatnot is believing that just because someone looks like something that they must be acting like everyone else that does that. But yeah, not correct.
Also, I had to ask Hypatia about this, but he said he couldn't solve it.
That's okay. So this is physics. So physics deals with, and yeah, Noyce is right here, the Suvat equations. I love that I've only learned that they're called Suvat like literally in the last month. We call them the kinematics equations. I like Suvat though. Suvat is Suvat's greater than everything. Yeah, I agree.
Hey,
Wait, I can just write them. What's up, dude?
Noise said something about like using a formula. I think it was this formula, but I showed the working, and he said that there was like a bad way or something.
Okay, yeah. Well, there's a couple equations. So these are called, we call them the kinematics equations. In England, they call them the Suvat equations. So I don't know which one you're gonna learn because you're in Belize, but let's assume it's this one. Minus 2a, and then this is delta x. And then I'm trying to think what the other one is. Was it v equals v naught plus at? These are all the equations we use, okay? And these are the things: position, velocity, acceleration, okay? And the key thing in physics when we do questions like this is to look at what are we trying to figure out and like what are we given, okay? So they say, and then these are technically final is what we say. Whatever, I'm going to use not, well, I guess I could use, let me use I here. Fine. Okay. All right. So, we have a dragster, Ethan, and it's accelerating to a speed of 112 meters per second, okay? So speed is what quantity here? Is that a position, a velocity, or an acceleration?
I think it's acceleration since they're technically the same.
So speed is velocity, is what we say. Well, velocity is speed with a direction. Okay. So
how is velocity related to speed here?
good. So velocity is the change in position over the change in time, right? It's how much distance it's the rate that you like change distance. Okay. And the only difference between velocity and speed is velocity has a direction. So I could say that, for instance, I'm going 50 miles per hour, right? That's a speed. But then I could say I'm going 50 miles per hour to the left, or I'm going 50 miles per hour to the right. That would be a velocity if we have a direction to it as well. Okay?
All right.
So in this case, we say it accelerates to a speed of 112 meters per second. This is what's called our final velocity. We're going to call this V final because this is the final speed we're looking at. We're going to say this is 112. Okay? Now, if I know the final speed is 112, what velocity or speed do you think it started at?
The speed?
Yeah. What speed did the dragster start at if it was like starting on the starting line?
Shouldn't it start at like 0 and then it goes faster?
Very good. Yeah. So I'm going to say that VI. So when we say this, Ethan, VI, I means initial. This means the initial velocity is what we say, which is like the starting velocity. Okay.
Oh, initial means the first.
Initial means the first. Very good. And then this is what we call the final velocity. Okay. And then they tell us that it covers a distance of 398 meters. So which variable do you think is distance? Is it acceleration, velocity, or position?
Okay, if it's covering a distance, I could assume it's like acceleration.
Close. So acceleration is how much the velocity is changing. Okay. Distance is related to like where you are, right? That's a position is what we say. Okay. And even more so, okay, a distance of 398 meters, that's what we're going to call delta x. Do you know what this triangle here means?
I keep forgetting. I need to write this down or something.
It's okay. This means the change. So this is the change in, and then this is position. Okay. So this thing covers a distance of 398 meters, which means it changes 398 meters in position. Okay. So that's what delta x is.
Okay.
And they're asking us to figure out the acceleration, right? So that's going to be a. We don't know what a is. Okay.
No, we don't.
So now what I'm going to do is I'm going to look at these equations and see which one of these equations has a VF, a VI, a delta X, and an A in it. And nothing else. I don't want any other variables that I have to deal with.
You know, this happened before you left, you know.
Oh, I know. Yeah, we did this before I left. It's okay. It's going to keep happening. It's physics.
Yeah, but then like there was like 5 of them, 5 of these different formulas.
Yeah, there's another 2 I'm just not writing just because to save time. But yeah. Okay, which one here, Ethan? Which one has delta X in it, VF, VI, and A?
You're talking about the one all the way to the right?
Yeah, these equations. Which one?
Which one has VX, VI, and A in it?
VF, VI, delta X, and A. Yeah.
I'm thinking it's the second one.
It is. And yes, you are right. Yes. Sorry. You're so right. There's a plus sign. Yeah, my bad noise. I get a little tired after an hour and 40 minutes of streaming. Thank you, noise. Yeah, it's the second one, okay? So I'm going to use the second equation, right? Which says that VF squared is equal to VI squared plus 2A delta X. The reason why I put the plus, the minus is because A is usually negative, because usually we're dealing with like things falling. And so I usually just put minus, but it's okay. Yeah. All right. So, Ethan, what's the last step I got to do here? I got my equation, right? I got what my numbers are. Yeah.
That you have?
Yeah, let's put the stuff in. So I'm going to put this into here, right? So that's 112 squared.
Which is like 0 squared, right? Which is just 0.
Good. Very good. Plus.
Which so 2A, which is still unknown.
Very good.
And then the change in position. I don't know what that is.
Well, that's the delta X here, right? That's the 398.
Oh, right.
That's how much distance the drag racer followed. Yeah.
Okay.
Ooh, thank you for the follow, KVO the KKX. That's cool. That's a cool name. Where's that come from?
Okay, so
yeah,
we can already eliminate the 0 since
yeah,
that's gone.
0 goes away. Okay. And then I need a calculator to do some of these other numbers, right?
112 squared, yes.
Yeah, 112 squared. Cool, that's 12544 is equal to 2 times A times 398. All right, almost there. What do we do next?
I think you multiply the 2 with the 398.
Yeah, we can do that too.
What if we do that?
We're gonna do it. We're gonna do it. That's 796. Okay, so let's get rid of this. All right. From a trilogy of book with only 2 books, KKKK. That's cool. I've never. Who's the author of those books? What do I do next here, Ethan?
I think you've got to get the A by itself.
Yeah. How do we get the A by itself?
Subtract 796 on both sides.
No, don't subtract. Don't subtract. What is the 796 doing to the A?
Oh right. I think you divide it.
Yes, divide. Opposite of multiplication is division. Divide by 796. Okay. So now I'm going to do this number divided by this number. And we're going to get 15.76, which is pretty cool.
So what was the actual question in that whole one?
They're asking what the acceleration was. They say what's the acceleration of the dragster? And that's what I figured out.
So I think it's like milliseconds per second or something.
Meters per second squared. Very good. That's what it is.
Oh, because in the answer it had like m/s/s.
Yeah, so the other way to write this, Ethan, is to write m/s/s. But really, you would write this like this. That's the real way to write it. Patrick Rothfuss.
And also they had that thing rounded off to like 15.8.
Yeah, you can round this to 15.8. Yeah, that's okay. We can do that too. This is actually pretty cool. Have you ever heard of like G-force before?
I'm thinking I'm wondering which one it is. It's like sending use on computers, or is it a dream?
Oh, well, yeah, okay, yeah, G-force is a video card thing, but what it really refers to is like how much like gravity you feel. Like, for instance, if you take a turn like really fast in a car or whatnot, you'll feel like a certain number of G's. And what we say is that like one G is equal to 9.8 meters per second squared. So this is like feeling I guess 1.5 times gravity, like in the horizontal direction. You are always feeling gravity in the up-down direction because gravity is always pulling us down to the ground. But this is feeling gravity again, moving to the left and the right. Dude, thank you, Noise. Yeah, great. Good job. I'm glad we got the same answers. Thank you for telling me the plus sign, not the minus sign. Anyways, yeah, this is the final answer. Does this make some sense here, Ethan?
Yes, it does.
Nice. Good job.
Yeah, sorry I wasn't able to explain this.
It's
very-
okay. It's okay. You have it. You're the math god. I'm the physics god of some sort.
I would make an argument first made by Gödel that there
You were
is
trying
no
to-
such thing as a math god, but
There is no such thing as a math god, dude. What?
that's the first incompleteness theorem.
Here, what's your name? Sorry, Meta. What's the highest math science material do you cover? The sky's the limit, because Hypatia here is like a math grad student, and so she can go up to, I don't know, abstract algebra. Like if you really want to start going to some high level math, Hypatia is our associate professor, and she knows some really advanced stuff. Rampton helps me out with the higher level math than I know. He's really good at differential equations, linear algebra, all that stuff. I tend to stick to calculus and below. I have a PhD in physics, so I can do the higher level math, but in terms of teaching it, my real expertise is calculus and below. Abstract algebra is not undergrad. What? That's like grad
Yes,
level.
In the UK, it is.
Oh, is it?
Like,
Oh, the UK is more advanced. Yeah.
yeah, like US schools, I hate them because like they feed up students with 3 years or 2 years or 3 years of calculus. That
Yeah,
doesn't
there's a
really
lot of
relate to
calculus.
anything.
Yeah. We tend to like kind of top out at calculus. I mean, I know a decent amount of linear algebra, and I have taught differential equations. I probably don't remember it. Is the issue? I swear.
I think it's also about like how you learn these stuff.
Yeah.
A lot of times, like and honestly, I don't think the level of math has anything to do with like how difficult it is.
Yeah.
Like, for example, I know that some people really like, like analysis or like, and they find it easier, right? And then
Yeah.
maybe like geometry is a little bit harder, or like problem solving when it becomes like writing down like a problem that has some kind of like a real world application and then like justifying it. That becomes really hard for people who are on math because they don't work for like translating words to equations.
Right.
But like for me, that was like really easy. But then
Yeah.
I couldn't like, do any analysis. So I think it's also very relative. Like whatever your interests are, you can just learn it. I think abstract algebra like is like you can if you are doing well in high school, you don't even need to be good at calculus. Like you can learn abstract algebra. I think probably knowing linear algebra is a bigger tool for knowing like most of math. Like you can get away with like learning most of math without being good at calculus, but linear algebra I would say is the one that really carries over.
Mhm.
From my experience, I'm assuming maybe Hypatia can vouch for that, or I don't know if he thinks.
Yeah, I
it's-
mean, algebra, it's so this course categorization, linear algebra, abstract algebra, it doesn't really make like there are different kinds of theories like group theory or commutative algebra, which is like rings and modules over them, and then algebraic geometry. Those are very individualized things. For example, if you want to study groups, you probably a lot of times you don't really need to know. Well, they are also intertwined in a lot of ways, but like just go ahead and read whatever that interests you. For example, if you care about the monstrous moonshine, you can read about all you want about the classification of finite simple groups. If you care about Grothendieck and modern algebraic geometry, you can read all about commutative and non-commutative algebra if you are into quantization, as I said. Like don't be limited by horrible, well, not horrible, at least subpar, suboptimal, pedagogical decisions made by mathematicians who doesn't really care about how people learn or things like that.
Oh, good. All right, let me end real quick. Let me do the spinner wheel for end of this. Yeah, it's the spinner wheel. We'll do because Noise is. How late is it in England? Noise. It must be like 6 a.m. or something there. Okay, teacups in here. We got equity.
I don't think so. I think it's wait. What time is it? I think it might be 2 a.m.
Yeah. Here, let's do it. All right, everyone else who's still watching the stream and whatnot, put your name in the chat, and let me put you in for the giveaway we're gonna do. Let me see. Maybe I'll tell the students here. End of stream giveaway. Double bonus today. Ethan's here. Yes, good. Thanks, Ethan. You're here. And yes, I will do the fountain pen thing Noise on Wednesday because it is getting late and I don't want to keep up too late. KVO. Yeah, cool. KVO. Make sure you join our Discord because that's the only way I'm gonna be able to get you the prize. So if you don't know what our Discord is, here's our Discord. Discord education. There you go. What's up, dude?
Today's actually population 1 day, not 4 days.
Dude, I need to charge my like Oculus, dude. Here we got Riplaw on here too. Cool, Riplaw. Ooh, we got a lot of people here.
Today's actually VR Fortnite day. We have building and skin, the same thing.
What is this streamer? Why can't I see this person's name, dude? What? This is so annoying. One sec. Streamer mode is like messing up. One sec. Let me turn that streamer mode.
Yeah, I don't like streamer mode.
I don't like streamer mode. Like chill, dog. I want to see this person's name. Spicy Phoenix. There we go. Okay, got you, Spicy. Spicy. Anybody else I'm missing? Let me think. We got Spicy Riplaw. Riplaw. I'm doing another giveaway is what I'm doing. You have to rig it in favor of Noise, dude. Okay, cool. All right.
Rig it in favor of me.
Okay, I think it's everyone. All right, 3, 2, 1, spin. Who's gonna win? Who's gonna win? Who's gonna get it? Wow, Riplaw! Congrats, Rocky, dude. Yeah, good job, dude. Good job. A moment of silence,
This
please.
stream broke also.
Did it? Did we finally break the stream?
You whole thing. You're just clapping as the
Oh my god.
wheel is like constantly spinning.
That's too funny, dude. Okay. All right, let's end the stream on this. All right. Thank you everyone for coming back to the stream. I don't know why Windows is messing up, but we have been streaming for almost 2 hours, so I guess it's gonna eventually break. Next stream will be Wednesday. We're gonna do it an hour later. And then we'll do a golden hour this week and everything. We're back to our regularly programmed schedule. Big thank you again to Ramton and Hypatia for helping out when I was gone and also helping out during the stream. I love all of it.
Obviously.
Also, yes, all great, awesome.
I actually did all the work there, so.
I appreciate you. I appreciate you, man. You're good. Okay, cool. All right, if you want to keep hanging out, I will play some Fortnite with you guys if you guys want. Let me start that stream up real quick. Let's see if that streaming PC won't die. Like, I swear, if you leave a Windows PC running long enough, it just like shits itself. I'm just like, why? Like, I think it's all the updates it gets or something. Dun, 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 dun. And then yeah, Noise. We'll do the. I love it. You bought that fountain pen for me. We're gonna do that reveal on Wednesday. Let's do that. We'll do that at the beginning of the stream.
By the way, I think I figured out how to play Warzone. Like,
Oh, nice.
I got another streaming service that streams.
Okay,
everything.
Oh,
guys,
sweet.
everyone load up your,
You can play on
everyone
Wednesday
load up
then.
your Oculus Quest 2 and Oculus Quest. We're playing
Yes.
Population
I
1.
will play Population 1 with you. Let me charge my Oculus and then I'll play it with you maybe like Tuesday or Wednesday or Thursday or something. But okay.
Population?
It's a VR game. But yeah, if you want to keep
Cool.
joining us, hang around the stream. We're gonna go to actual gaming. I'll play some Fortnite there. If you're in the Discord, come over to the Recess voice chat. I'll end the stage here. And otherwise, I'm so glad to be back. It was awesome seeing all you guys again. I really appreciate y'all sticking around, even though I leave for 2 weeks. And we got a lot of fun things planned for the summer. So stick around. We're gonna have some fun. And I'll see you guys on Wednesday. Cool.
Yeah.
All right.
See you, everyone.
Peace.
Have a good day.
You too.
Later. Oh yeah, go. I forgot to. I got a new iPad.
Got a new iPad. That's dope. Here, can you drag us all to recess, Teacup? Can you drag us to recess?
Yeah.
Thanks, man. Appreciate that. Bum, 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 bum. There we go. Oh, I see. None of this was connecting for some reason. What's wrong with it? Okay, now it's connecting. I was like, why was none of my Sammy stuff working? It's whack. All right, let me. I think Fortnite had to update too, is what had to happen. So let me see. Make sure I got it.
Goodbye, Gold.
Goodbye. Okay, goodbye, Teacup. Goodbye.
I don't play Fortnite with you guys.
You should, dude. It's fun. You don't